Okay, it's 1 minute past 8 here in California, so I think we can start. So thank you everyone for joining. So the topic we have today is really around the Oracle database backup to the cloud, and specifically how to migrate backups that you or customers may have taken to AWS S3 through to the object storage service in the Amazon cloud if they want to move them to OCI. The suggestion we usually give is, if you have short-term potential backups that you keep for week to weeks, it's probably, and you want to move to the OCI object storage service. The easiest way of doing this is probably starting new with the OCI, installing the new database backup cloud module, and let the old backups expire in AWS S3. But if you have backups that you have to retain for longer term, it makes sense to just move them to OCI, and this is what we're going to cover today. So we'll have a short introduction on the database backup cloud service, what database backup cloud module is, and then we talk about how to move them from AWS S3 to the OCI object storage. So the database backup cloud service, you should probably be familiar with it. It's a backup service. It's a combination, if you want, between the database backup cloud module, which is an Arman SBT library that lets Arman send backup directly into the cloud, with the object storage cloud service. So it's made of two components, if you want: the database backup cloud module that you installed on the database you want to backup, and the OCI object storage service. The advantage of using this for backup even from on-premises is that you can easily send your backups off-site. Some customers have a requirement of storing backups off-site, at least certain backups. It's cost-effective. Object storage is not particularly expensive, especially if you want to retain backup for a long time and can take advantage of the archive storage service, which is even cheaper. It's easily scalable. You don't have to manage shipping tapes around and do this kind of stuff. It includes the database backup cloud service subscription includes the ability to use encryption and compression with Arman that usually require some database options license, like the advanced security options to use Arman encryption, or the advanced compression option to use Arman advanced compression. Okay, so with the database backup cloud service subscription, those options are not needed. You can still use them, and it's protected by the object storage service, always available, and 3 copies. The same service is used also for the database cloud service, Exadata cloud service. They're also backing up to cloud storage currently using the same module, but we will not cover that part. It's a little different. So we'll mostly talk about backing up from on-premises to AWS S3 or to the object storage, and how to migrate to the cloud, to the OCI. So the core component, if you want, that you install on the database that you want to protect is the database backup cloud module. As I mentioned, it's an SBT library. It comes with an installer module, which is a Java installer that you run on the database. You specify some parameters like the endpoint, so the region where you want your backups to go. You specify the user private key and the public key associated with it, the public key fingerprint associated with it. You specify the tenancy OCID, the user OCID, the compartment OCID if you want, and the bucket name. The bucket can exist, or if it's not existed, the installer will create it for you. And the installer will run and create an Oracle wallet where it stores the configuration, the credentials, so the private key and the public key fingerprint. And it will create a configuration file where it stores the configuration parameter again, like the destination, so the hosts where the backup are going to be sent, the wallet location, the wallet that was just created, and the bucket name and the compartment. This also downloads the SBT library that then it's used by Armen. So all you have to do, obviously, when you run the installer, you can specify the location where you want your library to be downloaded to. And all you have to do at that point is just configure your automatic channels in Armen, specifying the SBT library that you just downloaded, and you specify the location of the configuration file, that is the configuration file that was created by the installer. And that's all you have to do. Obviously, you have to turn on encryption. That's mandatory. If you try sending a non-encrypted backup to the cloud, you get an error. So it must be encrypted. And you can set the compression at the level that you want. Usually, sometimes, given the fact that object storage and the service are charged on a capacity base, so you pay for the storage you use, sometimes people think, okay, I'm going to use high compression, so I use less storage and I pay less. But high compression is very demanding on the CPU cycle for during backups. So sometimes it's not very performing. I mean, you may not take advantage of the bandwidth you have. So usually what we see, low and medium compression are the best options. And at that point, you are ready to do backups with all the usual and supported Armen commands. You can do, you have to do backup sets. Obviously, you can do image copy backup. And the library, the LibOps library, will take those backup pieces and send them to the cloud storage, to the bucket that you have configured. And again, you can use any Armen supported command to do that together with this. So when the libOPC sends backup to the cloud, it uses, as I mentioned, its backup sets. So it uses a parameter that's a format parameter, again, standard Armen parameter, to determine how this backup piece name looks like. And the parameter that we usually recommend to use is this one, percentage small d, percentage uppercase U, and this generates a backup piece name that is more or less something like this. So percentage D is the DB name, and then percentage U is a unique identifier that is automatically generated. In this way, you have the guarantee that you're not going to end up with two backup pieces that have the same name, and obviously that would be a conflict and a problem. So there's one guarantees that you're going to have unique names, unique object names. So Armen creates these backup pieces and send them to the cloud. When they are sent to the cloud, it takes this format. So it uses, first of all, a metadata file that is associated with the backup piece that is being created, and it's stored in this. I would say directory. It's not really a directory. Object storage is a flat space. Okay? So each object is really an individual object in a flat space, but we use slashes to kind of simulate a directory structure, right? And so you have this SBT catalog slash backup piece name slash metadata.xml, where Armen, the SBT library, stores some metadata information about this backup piece. And again, this is for any backup piece. So every time a backup piece is stored in the cloud, something under this SBT catalog slash backup piece is created. And it is this metadata.xml file. And then we have the actual data, the actual backup piece data that are stored using this file name format, which is file chunk. This is fixed, always starts like this, slash, then you have the DBID slash DB name slash backup piece, also fixed. And then you have the date. And then you have the backup piece name, the backup piece handle, okay, the backup piece that you actually handle, that you actually see in the Armen catalog if you do a list backup for it. And then you have slash, the incarnation, and slash a chunk number. This is because the backup pieces can be divided into multiple chunks. They must be very big for you to see with the current module. It must be above 10 gigabytes for you to see a number of chunks. If it's less than 10 gigabytes, you will always see a chunk number here, okay, which is 001. I have an example in a moment, so you will see how it looks. And then you have another copy of the metadata in the same location, so using the same name structure. This is how Harman stores through the libop this SBT library backups and backup pieces in the cloud. So how backup piece name translates to, or backup piece handles translate to object names in cloud storage. If you go and open the Cloud Console, you go to object storage and navigate to the bucket where you send in backup, you will see something like this, which is exactly what I showed you a moment ago. You will see the SBT catalog / backup piece handle / metadata.xml for all the backup pieces that are stored in this bucket. So it can be thousands or millions of objects stored in a bucket. And then you have all the file chunk, if you want, to the actual data stored. And here you see the number. Okay, 1, 2, 3, 4. This was taken using an old version of the backup. This is not happening anymore. In the past, we used 100 megabytes size for the chunk. Now we upload the chunks in a different way that they are recombined at a later time when the upload is committed. So up to 10 gigabytes currently, you would only see one piece. And this can also be customized through parameters if you want, but the default is this one. If it's more than 10 gigabytes, you will see a 001 object with 10 gigabyte in size, and then you will see object 2 with, again, up to 10 gigabytes. So if it's more than 20, you will see another one, etc. Plus the metadata.xml. So this is how they are stored. And you know, the reason why I'm telling you this is that because at this point, you can think about, I don't know, how can I move those backups now from one cloud provider to another, like from AWS S3 to OCI. The format is exactly the same for the library that we use for the OCI cloud, so the libopc that I mentioned, and also for the OSP cloud module for AWS S3, which is a similar module, if you want, with a different library, but it does the same thing. It lets customers upload backups directly from Harman to an AWS S3 bucket. But the format it uses for the backups is exactly the same, and they are totally compatible. It means that you can take a backup that was sent to AWS S3 using the OSP cloud module for AWS S3, and you can copy it to OCI, and nothing else has to be done. Everything works. You only have to install the backup module pointing to OCI, so that from Harman you can access the OCI bucket. And all the backup objects copied from AWS S3 bucket to OCI bucket work without any change. The catalog, the Harman catalog, whether you're using a catalog database or you're using just a control file, also does not need any change. Okay, everything works. The tool you can use is Arclone. I mean, you can use whatever you like to move and copy backups. The one I used successfully is Arclone. It is a free tool that you can download from arclone.org. You install it on a system. It doesn't necessarily have to be the system where you have your database running. It can be any system that has access to both cloud storage services. I tried running it from an OCI computer node. Works fine as long as you have internet access. And so you can read data from the AWS S3 bucket. So you download Arclone, you download the database backup cloud module from OTN, you install it on your database server that I assume currently is being backed up to AWS. And so you install it and you configure it pointing to the new OCI bucket. So you specify all those parameters for user OCID, tenancy, bucket name, etc., based on the target destination where you are going to move your backup to. You set up the secret access keys for the OCI user, and you have to do this because rclone uses S3 APIs to access OCI as well as AWS. So you need to set up these secret keys. You go to the OCI console, you go to user settings, and in user settings, you have this customer secret keys. You click on the generate secret keys, and you basically obtain the a key pair that the rclone will use to access your bucket. And then you set up environment variables. rclone also has a configuration file. You can run a configuration file if you want, specifying more or less the same parameters, or you can just use environment variables. If you run rclone and there's no configuration file, it will read the parameters from the environment variables, these environment variables. So you have a set of environment variables for the S3 configuration. So you specify, right, that this is going to be an S3 endpoint. You specify the access key and the secret access key to access your S3 bucket. You specify the region where the bucket is located, the AWS region, obviously, where the bucket is located. And then you specify this, the bucket name. Okay? So the source variable as stored in this format, S3 column, and the bucket name, the S3 bucket name, where you're currently sending your backups. And then you have another set of environment variables for your destination. The type is again S3 because, as mentioned, we use the S3 APIs in rclone to access OCI object storage. You specify the access key and the secret access key. This is the key pair that you generated from the OCI console. You specify the OCI region, and then you specify the OCI endpoint in this format. This is fixed based on the region. So if the region is Ashburn, like in this case, the endpoint is always in this format. So this is the namespace dot compat dot object storage dot region dot oraclecloud.com. This is in the tenancies created until probably 6 or 7 months ago, maybe more. This was the tenancy name. A few months ago, the object storage service changed this, and this is not the tenancy name. It became a kind of random string. It's automatically generated. So it does not match the tenancy anymore. You have to go to the object storage console in our tenancy and find it out. Or when you install the database backup cloud module, this is automatically found for you by the installer. You will find it in the database backup cloud module configuration file. It's not difficult to find it anyway. And this is how you set up your endpoint. And when this is done, you can just start the copy using rclone. This is the command I used. You can customize it based on your need, but this works fine. It has 64 workers if you want. And you copy from this $source, which is one of the variables we set before, which is S3 column bucket name, to OCI column bucket name. This is the bucket destination when your backups have to be sent to. And that's all. There's nothing else to do. After this, you can start Arman and do a restore validate, and everything should work. Arman will show that the label changed because the label that is in the Arman catalog and that was showing the S3 bucket is updated, showing now the OCI bucket once Arman reads data from there. But that label is just a label. It's not used by Arman to find the backups. And that's why you don't need to do anything. Even if the label is still pointing to S3, the first time you try to access that backup piece, Arman updates it automatically. So really nothing has to be done, and you're good to go. And when you have all your backups moved from AWS to OCI. If you want to find out more information, here there are a couple of docs that you can look at. The first one is a white paper about transferring data to object storage from other cloud providers or local file system as well. This is an object storage white paper. It's the white paper I use to find out about our clone configuration, etc. If you want to use it for copying other data, it's a good place to read. Or if you want to find out more about our clone, that's what you can look at. The same approach can also be used for moving backups from an OCI Classic container to an OCI bucket. And we have a runbook about migrating database backup from the OCI Classic to the OCI object storage. It's linked here. We'll provide a detailed link later, but yeah, you will find all you need to do to move backups from OCI Classic to OCI. I think that's all. If you have any questions, you can probably unmute yourself, or you can ask question on the chat.
Also, this is Tim. I just sent a chat question of a poll for people who are using cloud backup service or will be planning to.
As I mentioned earlier, this is open to also any other questions that may not be related to this topic specifically. So if you have other questions, feel free to ask, and we'll try to answer them.
Marco?
Okay, yeah, go ahead, Tim. Ken.
In the chat, someone mentions that they're planning to use AWS S3 for backup. And the one comment I wanted to make about that is, Marco at the beginning talked about the database backup cloud service for OCI and what's included from a licensing perspective. So be careful of that when you're targeting S3, because there's license requirements are different. So you don't want to get yourself in a trap where you're not licensed for the operations you're performing.
Yeah, that's correct. The S3 also cloud module has licenses, right? You need OSP licenses per stream. So based on the number of channels that you want to allocate backing up to the AWS S3 bucket, that's what you have to count for in terms of licenses, OSP licenses. The other thing that I want to mention is that the module itself does not support natively the Glacier storage, which is the Amazon equivalent of our archive storage. So yeah, just S3 is supported. Okay.
Yeah, I would just say, Marco, that we always need your feedback on relevant topics. We try to present kind of what's latest and greatest, and at least highlight what's available so that you can kind of get updated on our latest technologies. But we're always welcome to to listen to additional topics you want to hear about. We can't triage issues and SRs specifically on this call, but we can definitely talk broadly about certain topics and so forth. So just let us know through the Ask Tom website about the topics you want to hear. And Marco, there's a chat question about the link to the 2 white papers, because we don't upload the slides to the session, only the recording. So can you?
Yeah, that's right. I was talking, but I was muted. I'm doing it. So let me do this. So what I was saying is that we can post them on the Ask Tom website, but I'll do it here so everyone has them. So okay, yep, this is the first one, the rclone one, if you want, about generic copying data to object storage from other providers or also from file system. The second one is the runbook for migration or migrating backups from OCI Classic to OCI, which uses the same approach, by the way. So I'll give you a moment so you can copy these links. And then again, if there are no other questions, I think we can.
I just sent a link for the S3 backup documentation. So
okay, thank you.
Yeah.
Kiran, do we have any competitive differentiation on our backup and recovery solution versus that at AWS, Microsoft, etc.? So currently we don't have a backup module for Microsoft Blob, Azure Blob Storage, if that's what you're referring to. We do have a backup module for the AWS S3, as mentioned, that's called Oracle Secure Backup Cloud module. The module itself is, from an architecture perspective, work in the same way, right? Both for OCI and AWS. The main difference is that the AWS module is just supporting standard storage, whereas the OCI one, so AWS S3, as I mentioned before, not Glacier. The OCI database backup service and database backup cloud module support both standard object storage and archive object storage. You can use lifecycle policies so that you can define that, for example, you want to keep backups for, 7 days in standard object storage from where you can restore immediately, very quickly. And after that, you want to move your backup to archive storage and keep them in archive storage for a longer term, where it's a lot less expensive to store. But in case of restore, you have a delay because you need to stage the data back to standard object storage before you can actually do the ARM and restore. And that's the flip side, if you want, this situation. The movement between the two is managed, by the object storage when you go from standard object storage to archive storage, because you use the object lifecycle policies of the object storage service, and then it's managed by Arman when you want to do a restore. It means that you can do an Arman restore preview to list if the backups you are trying to restore is already available in standard object storage or if it's in archive storage. So it means to have, it needs to be recalled. And you can do an Arman restore preview recall if you want to initiate the recall from archive storage back to standard object storage. And after that, you can do an regular Arman restore and restore your database. Or you can just do an Arman restore right away, and if the data is in archive storage, Arman will initiate the restore from archive, wait until the data is available in standard object storage, and then proceed automatically. So it's all integrated, okay? And the AWS S3 module, we don't have these functionalities integrated with Glacier, etc. We just want the backup to be in S3. Anything else you do has to be managed manually by you. These are the two main differences. The other difference is that on AWS S3, you have to buy and pay for the licenses for the OSP Cloud module, and in the OCI, you pay based on capacity. Just you pay for what you use, and that's it. And it doesn't matter if you're backing up using 1 channel, 10 channel, 100, or the 1,000 channel at the time, doesn't matter.
And with the pricing, Marco, of cloud backup service versus S3 service, the actual subscription pricing our cloud backup pricing is fairly competitive. Is that correct?
Yeah, it's competitive. It's difficult to, especially with keeping track with the Amazon pricing, which is there's a lot of different little options and components, and then it changes region by region. We don't have anything like that. We just have a flat price. You pay for the object storage you use, which is one price. You pay a little uplift for the database backup cloud service, and that includes the compression and encryption options, etc. And that's it. It's a fixed price. You pay for what you use. But in the end, the actual cost from a storage perspective is very similar. On the AWS side, you have to also pay for the licenses. That's the difference. All right. I don't see any questions at this time. So last chance to add anything. Otherwise, I close the call. All right, then. Thank you, everyone, and we'll see you at the next office hours. Okay. Thank you, and have a good day and a good weekend.